These are going to be expressions that are binomials that contain radicals. And we all know our vocabulary well enough that that makes perfect sense. Something like 4 plus 2 square root 3. This is a binomial because it has two terms, right? That's what bi means 2. So it has two terms, and there is a radical present somewhere. That's all binomial radical expressions means. Basically what we're asking here is, do we have like terms? And with radical expressions to be like terms, you need to have the same root here and the same exact thing under the radical here. So in part A, we are going to end up with 19a square root 7bc. Just like when you're dealing with variables, if you have like terms, if the radicals match up, then 14a plus 5a is 19a, but the radicals themselves stay the same. Just like if you had 2x plus 7x, you get 9x, noticing that it's x all the way through. The x doesn't change. In this problem, it's a radical all the way through. Doesn't change. Okay? The simplified form in part B. 3 times the fifth root of x minus the fifth root of 3x. That is the simplified form. The roots match up. It's each a fifth root. But what's under the radical is not identical. So you cannot combine these. If that had been 3 times the fifth root of x minus the fifth root of x, that would have been 2 times the fifth root of x. But the presence of this 3 here means that we do not have like terms, therefore we cannot combine. Find the perimeter of the tile to the nearest tenth of a foot. So those 4 right triangles, here, 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 and here, are all the same exact size. They all look like this. So we need to find this length, x. Because up here in the square, this is x, this length is x, this length is x, and this length is x. So we need to know what x is. We use the Pythagorean theorem. 1 squared plus 2 squared equals x squared. So x is the square root of 5. The perimeter is root 5 plus root 5 plus root 5 plus root 5. It is this length plus this length plus this length plus this length, which is 4 root 5. They ask us to round to the nearest tenth, and rounded to the nearest tenth, that is going to be 8.9 feet. The roots here all match up. It's square root, square root, square root, but the numbers underneath the radical do not, so we do not have like terms. So what we want to try and do is simplify them. So root 28 is root 4 times root 7, minus root 175 is root 25, root 7, and root 63 is root 9, root 7. So after we simplify them, we have 2 root 7 minus 5 root 7 plus 3 root 7. When we combine these, now that they are like terms, we get 0 root 7. 0 times anything is 0. When we see a binomial multiplied by a binomial, what do? FOIL. So in this problem, we get 4 minus 3 root 7 plus 8 root 7 minus 6 root 49. Continue to simplify. We get 4 plus 5 root 7 minus 6 times 7 which is negative 38 plus 5 root 7. Up here, when you see these two, hopefully the word conjugate either comes to mind, or now that I've said it, you realize, oh yeah, those are conjugates, because it's 5 plus 3 root 2, 5 minus 3 root 2. When you FOIL conjugates, the middle terms should cancel. We get 25 minus 15 root 2 plus 15 root 2 minus 9 root 4. So, like what should happen with conjugates, the middle two terms cancel out to 0. We have 25 minus 18, which is 7. The main idea is that with binomial radical expressions, if you multiply a binomial radical expression by its conjugate, you will get something that does not have a radical in it at all, which is why this is helpful. So here we have 11 over 6 plus root 3. To get rid of the radical in the denominator, we multiply by the conjugate in the numerator and in the denominator, so that we're multiplying by a total of 1. So we get 66 minus 11 root 3 over 36 minus 6 root 3 plus 6 root 3 minus 3, which is 66 minus 11 root 3 over 33. So the example I always use here is, does 3 plus 2 over 3 equal 2? No, because we cannot just cancel here. If I want to cancel out, if I have a 3 here and a 3 here, if I want to cancel these 3's out, I have to be able to cancel a 3 out here, because this is clearly not true. So in this problem, if I want to cancel out here, whatever I cancel out here, I have to be able to deal with here as well. Okay. What we can factor out is an 11, so we get 6 minus root 3 all over 3, which I would accept this. This could be rewritten as 2 minus 1/3 root 3. I would accept either one. Hopefully we notice that complex numbers and binomial radical expressions, the algebra ends up being very, very similar, doesn't it? Even the division there, you multiply by the conjugates. That's exactly what we did with complex numbers. Why do you think the algebra ends up being so similar with complex numbers and binomial radical expressions? So the general form of a complex number is a plus bi. So we really have a plus b times the square root of -1. So why do you think that complex numbers, the algebra with complex numbers, is very similar to the algebra with binomial radical expressions? These two sections, complex numbers and then all the math with binomial radical expressions, the processes seem so very similar because a complex number is a binomial radical expression, right? It is a binomial radical expression. So why does the process seem similar to binomial radical expressions? Because it is a binomial radical expression.